Welcome to Intermediate Algebra, Chapter 1, Section 4. In this section, we're going to talk about solving linear inequalities, and this is going to be a pretty quick lesson. We're going to talk about these different formats for presenting final answers, and then we'll look at solving an inequality and presenting our answers using the variety of different notation for presenting our solution, and then we'll work an example problem, and then you'll be off to do homework. So let's have a look. In case you aren't familiar with all these or need a little reminder, a little slow going on that refresh. There we go. So in the left-hand column, we're seeing typical inequalities. So this says x is less than 3, which using English means that we're looking at or considering as a solution all of the x values that are less than 3. On a graph, less than or equal to 3, on a graph we want to shade the entire number line to the left of the number 3, including the number 3, and we're including it using a square bracket. In interval notation, which is maybe the most common notation for expressing the solution to an inequality, we see that the shading of the number line goes all the way down to negative infinity. That arrow on the left end of the shading says that the shading goes all the way down, and it comes up to the number 3 and hits a square bracket there, and we're seeing that same square bracket in interval notation. So translating from or starting with a shaded number line and then moving to interval notation is really nice because we're going from that visual representation and using pretty much all of the same little bits of notation in order to write our solution in interval notation. And finally, set builder notation. I feel like that column should really be by this left-hand column because these are so similar. The only difference being that we're putting that inequality statement in these set braces, and I'll talk through the language that corresponds to each one of those symbols as we do our first example problem. Also take note in this second to last column here that anytime you see infinity or negative infinity, that it is accompanied by a parenthesis or an open bracket. And I remember that it always takes an open bracket because I can't ever quite get down to negative infinity or up to positive infinity to include it in my solution. And since I can't ever really include it, I must be excluding it, which we do with that parenthesis or open bracket. So let's see what happens as we work through this example. In order to solve this inequality, the first thing I'm going to do is pretty much anything I can in order to get rid of that fraction on the right-hand side. So let's rewrite it over here. 1 is less than 2x plus 5 over negative 6. This problem's also really nice because the first thing we're going to do is multiply both sides by negative 6, so it works very much like a regular equation. What you do to one side, you must do to the other. 1 times negative 6 is negative 6. The negative 6's are going to cancel on the right-hand side, leaving us just with the 2x plus 5. And here's the thing you need to take special note of. Anytime you multiply or divide both sides of an inequality by a negative number, as we're doing here, you need to flip the sign or change the direction of the inequality symbol. So in your notes, make sure that you take special note of the fact that this symbol has changed into this symbol as a result of the fact that we multiplied by a negative number. Write it out using whatever kind of language you want. Highlight it, put stars on it, different colored pen or pencil, something, but you don't want to forget to make that maneuver. And from here on out, it's pretty straightforward and similar to working with an equation. Let's isolate the x value on the right-hand side. So subtract 5 from both sides. We've got negative 11 is greater than 2x. I'll then divide both sides by 2 in order to get x all alone. So I have negative 11 halves is greater than x. This is a pretty good way, or it's definitely one of the ways of expressing your final answer. I would tend to sort of flip this entire statement if I were going to write it as a final answer. So let's, I'll write or x is less than negative 11 halves. Notice that the x is still on the pointy side of that inequality symbol. It's still on the less than side. The 11 halves is still negative in both of those statements. They are equivalent. It's just more typical to see it written this way. So I'll even go ahead and put a box around that one and say that this is one acceptable way of representing my final answer. Or we could take this, and in that second to last column that I pointed out, let's put this into set builder notation right away. And I told you I would talk through the language of each individual symbol, so it shapes up like this. It's the set of x values such that x is less than negative 11 halves. And then we'll close our set braces. So again, this is set builder notation, and you may be asked in your homework to present your answer using this notation. And this is the best way to write it. In a multiple choice scenario, you could see it written using this notation. Usually it's reserved if you have more than one restriction on x. But you might run into this. Or we could see this on a number line, and I'm going to put my number line up here, and I'll show you why. If 0 were out here, and you don't have to put 0 on your number line, but I like to put it as a reference value, and here's the negative 11 halves, I'm shading everything to the left of negative 11 halves because I'm interested in the x values that are less than negative 11 halves. So let me use this sort of a highlighter here. That's too big. I'll shade to the left of negative 11 halves. I'm going to make sure to turn that into an arrow so that it's shading all the way down to negative infinity. And I'll switch back over to my pen here so that I can put a parenthesis, or we call it an open bracket, at the negative 11 halves, which means we are not including negative 11 halves in our solution. This is your answer graphically on a number line. And then let's convert this into interval notation. I love going from the number line into interval notation because we can read it from left to right and rewrite it using interval notation from left to right. How far to the left does that shading go? It goes all the way down to negative infinity. And as I told you, negative infinity and positive infinity always take a parenthesis. And then the shading as we go from left to right comes all the way up to negative 11 halves. There it is. And we are excluding negative 11 halves because this is a strict inequality. It does not include the or equal to symbol. So we are excluding it with a parenthesis. We call this an open interval. In fact, it's open on both ends, because it has parentheses on both ends. So this is the other very typical way that you'll be asked to express your solutions to inequalities. And my students are going to see homework assignments or a homework assignment that corresponds to this section that asks them to do multiple problems of this type so that you get very familiar with these different types of notation. Now let's check out an applied problem. This one says that Alicia has earned scores of 72, 86, and 84 on 3 of the 4 exams in her biology class. What score would she need to earn on her 4th exam to have an average of at least 80? Let's translate just quickly. Average of at least 80. It's not even average of, it's just really this part, at least 80. What does that mean to you? Could it be 79? Is that at least 80? It's not. What about 80? Is 80 at least 80? I would say yes, and it's probable. I mean, you can imagine that, because if she wants to get at least a B or a B minus in the class, she needs an average of 80 or better. So as we translate at least 80, think of it as 80 or more. We could even go one step further and say greater than or equal to 80. And in fact, that's what we're going to use. Now it's her average that has to be greater than or equal to 80. And how do we calculate the average of 4 test scores? We add them together and divide by the number of scores. So let's set it up. We've got 72 plus 86 plus 84 plus her unknown test score. We're going to average all those by dividing by 4. And the result of that needs to be at least 80. The average greater than or equal to 80. And now it's an arithmetic problem. Let's multiply both sides by 4 in order to get rid of that fraction, just like we did in the previous problem. So if you want to write out the entire numerator again, and on the right hand side you'll have, this time it'll say greater than or equal to 320. Or you can do the arithmetic that's on the left-hand side in the numerator, and I can do complex math in my head sometimes, but I don't roll the dice when it comes to arithmetic. So I'm using a calculator to do 72 plus 86 plus 84 equals, and that's 242, and the x is still there. So this is our new inequality. And if you want to make sure that all the pieces are matching up, you could highlight the fact that it's these values that gave you the 242. Let's subtract 242 from both sides. And we have now a statement that says, and don't roll the dice, use the 4-function calculator even if that's all you're allowed to use. I've got 78. So she needs, on her last test, to get a 78 or better, in other words, at least a 78, in order to get an 80 in her biology class, or to have a test average anyway. So let's present this solution using our 4 different methods. This is one of them, and I'm seeing the x on the left-hand side of that statement that I just put a box around. And as you'll see, my preferred format was to have x on the left-hand side of the solution. Let's put it into set builder notation. The set of x values such that x is greater than or equal to 78. That's set builder notation. The next one that we did was a number line. Here's 0. Here's 78. We want our scores to be greater than or equal to 78, which means I'm going to be shading to the right of 78. And should I shade this all the way out to infinity? It depends on the software that you're using. If you're completing a homework assignment online, it depends on how your instructor wants you to frame this up. If it's a handwritten question, it depends on the software used. If it's a multiple choice question on a quiz or a test. Outside of a word problem, I would probably put an arrow on this thing and send it all the way to infinity. But if we wanted to be a little bit more specific to this word problem, I might stop it at 100. Assuming that she can't score higher than 100%. Is a score of 78 acceptable? Are we including the score of 78 in our solution set? We are, because this says or equal to. So I'm going to translate that into a square bracket, which is very similar to what we used to do when we were younger. We'd put a solid dot on the number line. And our shading's going all the way up to 100. Would a score of 100 on her fourth exam be acceptable? You bet. It's a possible score and an acceptable score that would keep her test average equal to or over 80%. So I really like this as a number line solution. And if we turned that into a solution using interval notation, we take the 78, bring it down, take the 100, bring it down, and grab that same notation of square bracket, or closed bracket around the 78 and on the 100. So I think these are the scores that she should be aiming for on her fourth test. Now, these two don't correspond exactly to these two, because this tells me, outside of a word problem, if I'm just looking at this purely mathematically, that an x value of 1,000,000 would satisfy that statement. So let's also talk about the fact that, again, depending on what software you're using, etc., that we might not want to enter these two options as our solution. Just from a purely mathematical standpoint, on our number line, here's 0, here's 78. We're shading to the right. And if we could get a score on our exam of 1,000,000, that would be super. The score of 78, however, as a low score, is acceptable, so we're going to include that in our solution set. This would be an acceptable number line or graphical representation of our solution set. All the x values bigger than 78. If we translate this number line into interval notation, the process is still very similar. The 78 is the low score from left to right. Positive infinity, right? The number line goes on forever, so she could score infinity. That'd be nice. That would give her a good cushion going into the final exam. She could probably get a 0 on the final if she scores infinitely many points on that last chapter test. We're including the value of 78, but since you can't ever actually make it out to infinity, we're going to put a parenthesis on it because it can't really be included. This is another possible solution, again, depending on your instructor and the software, etc. So another good example of the 1, 2, 3, 4 different ways that you can present your solution set when you're working with an inequality or a linear inequality in one variable. Hopefully that gives you all the help you need in Chapter 1, Section 4, and I'll see you in Section 5.